Okay, good morning, students. Today we are starting with the first lecture of data structures and algorithms, having subject code 210252 in Savitribai Phule, Pune University. It's a course for second year computer engineering, and it is in pattern 2019. Okay, so we are starting with the first unit, that is unit 1, hashing. Okay, so in this unit we are going to study hash table data structure and its related terminologies, as well as the problems and their solutions, which we can find using hash table or hashing. Okay, so today we are going to see the basic concepts in hashing. So let us go ahead and start with the basic concepts. So these are the basic concepts that we are going to see. First of all, we are going to see what is hashing. After that, we will see what is a hash table. Now, hashing is different, hash table is different. That is why we have written two different questions over there, that what is hashing and what is a hash table, right? After that, what is a hash function? What is a hash function? Then we'll see basic operations on hash table. What are, like every data structure has some basic operations. Similarly, hash table will also have some operations. So we'll see what are the basic operations on hash table. After that, we will see what is bucket, what is collision in hash table, what is called as a collision in hash table. Then we'll see what is probing. Then we'll see what is synonym, what is called as a synonym. So it's a term, right? These are the terms which are used in hash tables. After that, we'll see what is overflow. That is what is a hash table overflow. And then we'll see what is load factor or load density. And at the end, we will see what is full table. Okay. So these are the concepts, basic concepts which belongs to hash table, hashing, hash table, hash function, basic operations on hash table, bucket, collision, probing, synonym, overflow, load factor or density, and what is a full table, what is called as a full table, and what we can do after the table becomes full, right? So shall we go ahead with the first concept, that is what is hashing. So here the first concept, that is what is hashing, right? So as I said, there is a difference between hash table and hashing. So hashing is a process and hash table is a data structure, right? So hashing is a method, is a technique, or is a process which we use to store the values, to map the values in the hash table. Okay, like each data structure stores some values, right? Like array stores values, linked list stores values, trees and graphs also stores values. Okay, so by using this hashing process, what we do, it's a process to map a key or value from user. Okay, so user को जो भी values store करनी है, जो भी values place करनी है in a hash table, तो वो कैसे करेंगे? Using this hashing process. So it's a process. So it includes keys, then hash keys, then hash function to generate a hash key, and then a location or index of hash table where this key or value is placed, right? So hashing is a complete process. Hashing is a complete process starting from which value is to be stored in a hash table till at which location it is stored using hash function. Okay, so it is a complete process. So it's a process of mapping a key or a value into the hash table. Mapping matlab kya? Storing a key or value into the hash table using some hash function. And it is done for, why we use hashing? For a faster access or storage of elements. For a faster access or storage of elements. The efficiency of mapping, this what we do, this mapping of the key to the location of the hash table. So this efficiency of this mapping depends upon the efficiency of the hash function. So जितना अच्छा hash function हम use करेंगे उतना efficient ये mapping होगा. So what is the mapping? Mapping of a key or a value, storing of a key. Mapping means storing a key or value into the hash table. So ये किस पे depend करता है? Efficiency of the hash function. आपका hash function जितना अच्छा रहेगा उतना ये process क्या होगा? Fast होगा, efficient होगा. Like, okay. So consider like in array, in linked list, in stack, in queue, everywhere we can store the values and we do some operations. So one of the famous operation is searching. One of the famous operation is searching, right? So what we do in searching? We find a particular value, a key value from a list of values, right? So suppose there is a problem. Suppose there is a problem. So what is that problem? We have a list of 20,000 numbers. We have a list of 20,000 numbers. And you have given a number to search. You have given a number to search in that list of 20,000 numbers. So what is the solution? How you will search? Either you will search it by linear search, or you will go for binary search, or there is a sentinel search, Fibonacci search, or index sequential search, right? So these are the options available to you, right? But if you go for linear search, it will take how much time? O of n. If you go for binary search, it will take time of log n, right? But linear search is very time consuming. Binary search is less, it will take less time than linear search. But hashing will give you the minimum time. In minimum time, you can find out a key value from a large list of values. That is hashing. Okay. So we have a problem of finding or searching an element in a large list of values in a large database. Okay. So we will solve this problem using hashing. Okay. So have you understood what is hashing? It's a mapping of or storing a key or value into the hash table using a hash function. So how we can understand it better? So here is a figure, a diagram using which I think we can understand it better. So these are the keys. Okay, John Smith, Lisa Smith, Sam Doe, Sandra D. These are the keys, right? And there is a hash function which is using this each and every key to generate their location in the hash table. Their location in the hash table. So what is a hash table? Suppose we are implementing hash table using array. So if hash table to be implemented using array having size 10. So if there is 10 size, array का size कितना है 10. So कितने locations रहेंगे उसमें? 10 locations, right? So these are ranging from 0 to 9. Okay, index will be from 0 to 9. So what is the job of hash function? Processing the key value जो आपको स्टोर करनी है. कहाँ पे? हैश टेबल में. So आपको हैश टेबल में क्या क्या स्टोर करना है? 4 key values like John Smith, Lisa Smith, Sam Doe, Sandra D. These are the 4 key values जो आपको कहाँ पे स्टोर करनी है? हैश टेबल में. तो हैश फंक्शन का काम क्या है? It will take John Smith and it will use a hash function to generate an index of the array. An index of the array, which is nothing but a hash table. That array is nothing but a hash table. So John Smith के लिए उसने index generate किया 02. Lisa Smith के लिए उसने index generate किया location 01. Sam Doe के लिए location है 04 and Sandra D के लिए location है 02 again. So जॉन स्मिथ एंड सैंड्रा डी, ये देखो दोनों के लिए एक ही लोकेशन जनरेट हुआ है. किसने जनरेट किया ये? hash function में. So hash function is generating a location, okay, like for John Smith and Sandra D, it is a common location generated by hash function. So what is this called as? If multiple keys are mapped, if multiple keys are mapped to the same location of the hash table, what is this called as, and how to handle this, that we will see ahead. Okay, so इसको क्या बोलेंगे एंड इसको कैसे हैंडल करेंगे ये हम आगे देखेंगे. Okay, so till now you should understand what are keys. So keys are the values to be stored in a hash table. What is a hash function? It's a function which processes keys and generates a location or index of the hash table, right, where that key can be stored or mapped. And what is a hash table? That we will see ahead. So here we can see what is a hash table. So hash table is a data structure, right? So we know that hash table is a data structure. So what it does, it stores data in an associative manner. So what is that associative manner? That for every key, there should be a unique location in the hash table. So that is a association between a value to be placed, okay, with the location of the hash table. So that is why hash table stores the keys, the values, the elements, the data in an associative manner. Okay, so there is an association between the value to be placed and at what location it is placed. Okay, so that association is created by, who creates this association? A hash function. Okay, so between the hash table and the values or keys to be placed, there is a hash function, okay, in between. So in a hash table, we can see that data is stored in array format where each data value has its own unique index value. Okay, so to store the keys or values, we use hash function to generate that unique index value. Similarly, to access those keys or values, we use the same hash function. Okay, because that hash function will only give us the location where the keys or values are stored. Okay, that unique index. Okay, so access of data becomes very fast if we know the direct index of desired data. So कैसे पता चलेगा आपको? How you will know that what is the index for the desired data, desired element? Because that element will be processed by hash function and it will give you its location in the hash table directly. So you don't have to go for linear search, neither for linear search nor for binary search. So you can directly get the location. So which is the fastest search here? Hashing, right? So hashing is the most efficient technique if each value placed in a hash table at unique index. Okay, so we have seen one problem also. What is that problem? When multiple values are mapped to the, like here, John Smith and Sandra D are mapped to the same location. So this is a problem, right? So we'll see what this problem is called as and how to handle this problem. Okay, otherwise a hash function must generate a unique location for each and every key, right? So in that case, searching will be the fastest searching, it will be efficient searching. So when we do insertions, search operations, they becomes very fast, and for that hash table uses most of the time array as a storage medium. So हम hash table को array use करके implement कर सकते हैं, and it uses a hash technique, that is hash function, to generate an index where an element is to be stored or inserted, as well as is to be located. So जब आपको insert करना है तो hash function आपको वो index देगा जहाँ पे आपको index को element को place करना है, right? And when you want to access it, hash function will generate that index where it is available. So in both the cases, hash function will generate same index for a same key value, right? So here you can see an example of this hash table. So here you can see there is a key value, that is actual data to be stored in a hash table. Then that key value is processed by hash function to generate a location, an index of the hash table, right? So वो जो location है, so that location is nothing but hash value, right? So that hash value can be anything from first location to the last, right? And this is how we can implement hash table using array. So if we have an array of size n, so how many locations it will have? 0 to n. How many locations it will have? 0 to n. So every time when we try to place a value, so that value is considered as key. It is called as key. Okay, the value to be stored in a hash table is called as key. That key is processed by a hash function to generate index of the hash table, which is nothing but an array. So that index is called as hash value. And at that index, we will place the key value in the hash table. So this is when we store, when we place the values. And when we want to access, we again, suppose I want to access a particular key value. So I will again pass that key to the hash function, and that hash function will tell me at what location that key or value is present, right? So I will directly get the location where that key or value is present. So are you understanding that it is faster than linear search and binary search? Yes or no? So next is what is hash function. Okay, so we'll see now what is hash function. So this hash function is nothing but a function, okay, a mathematical function which will accepts a number or a string as a key value and then convert it to a smaller integer value, okay, which is nothing but a location or address or an index of a hash table. So this is done to map. Or to store the values into the hash table, right? So that mapped integer value is nothing but an index if we are implementing hash function using array, right? So for example, if we have a key, so we can use a simple hash function here for an example. So for an example, key mod table size will give you the index, of hash table. For example, मुझे store करना है, I want to store 345 in a table of size 10. I want to store 345 value, key value in the table, hash table of size 10. So the index will range from, if the hash table is having size 10 and it is an array, so index will range from 0 to 9. So my hash value or hash key should be between 0 to 9. Should be between 0 to 9. So for 345 mod 10, I will get the index or location 5, where I can store 345. Right? Suppose you have a value like 50. Okay, 50. So what is the location hash key for 50? What is the hash key if the key value is 50, 50, using this hash function?
0.
Yeah, it will be 0, right? Because 50 mod 10 is 0. So 50 will be stored at location 0 of the hash table, right? Now, one more. If we have a key value 999, okay, 999. So what is the hash key? What is the hash key? At which location 999 will be stored?
9.
9.
Yes, location number 9. So when you use a particular hash function, it will always provide the index or hash keys of the locations which are available in the hash table. Like your hash table is of size 10. So for every key, it will not generate the location smaller than 0 and greater than 9. Okay, so that is the magic of a good hash function. Okay, so when we say a good hash function, so what are its properties? That it must generate the index values which are available in the hash table. That is first. Second, it must be efficient in computations. It should not take much time to generate a location of the hash table, to store or to access the keys, and it should uniformly distribute the keys. Like suppose there is a table of size 1000, hash table of size 1000, so there are 1000 locations. So when we map the keys or values, when we store the keys and values in the hash table using hash function, so it should not happen that most of the keys or values are being stored between 0 to 500 locations, and there are very few key values are placed or stored between 501 to 999 locations. So a good hash function always uniformly distributes the keys to be stored in a hash table or while storing in the hash table. Okay, so that is a good hash function. So this is all about hash function. So it's a mathematical function which converts a number or a string into a location or index of a hash table. Now, what are the basic operations on hash table? What are the basic operations on hash table? So these are the basic operations on hash table. Number one, search. Second is insert, and third is delete. So you can understand when we do search, what we do actually, we search an element in a hash table, right? So how we do this search? We will have to specify the key value which we are searching, right? That key value will be processed by hash function, and then it will generate a location or an index where that key value would be present, must be present, right? So that is a search operation. What is insert? When we insert an element in a hash table, when we insert an element in a hash table. So how we do this insert? Again, what key value to be inserted? So that key value will be processed by hash function, and it will generate an appropriate location of the hash table where the key will be inserted or the value will be inserted. Now third will be delete. So what we do in delete? I will have to specify which value I want to delete. So for that value, hash function will generate an index of the hash table, and if it is present on that index, we will delete that element from a hash table. So through search operation, we search an element in a hash table. Through insert operation, we insert an element in a hash table, and when we delete an element from the hash table. But see, in each and every operation you need to specify, अगर आपको search करना है, then which key to be searched, if you want to insert, which key to be inserted, and if you want to delete, which key to be deleted. So every time you will use the same hash function to search, to insert, or to delete from a particular location or to a particular location of the hash table, right? So for each operation, there is a need of hash function. And if you are using a hash function to insert a value, you must use the same hash function to search or delete a value. Why? Because if you change the hash function, it may generate a different index. It may generate a different location where you will not find the value you are looking for, right? The value you are searching for, the value you want to delete, right? So these are the basic operations on hash table. Okay, so let us go ahead and see the next term, and that is what is a bucket. So we know bucket, right? So a bucket, like we have a bucket at home, we store something in it, right? It may be a water bucket we store, or we store water in it, right? So similarly, a bucket concept is there. It is a real life terminology, bucket. So in case of hash table, it is a single location. It is a single location of hash table where we store the keys, values, or elements or records. It's a single location of the hash table where we store a single value like a number or strings or a record in a hash table, right? So that is what a bucket, right? So that bucket is used to access a location, right? So when we want to store a value, we store that in a location of the hash table, and that is nothing but a bucket, right? So now we can have this bucket, and this bucket can store a single value, like I said, a single number value or a single string, or it may store number of values also. So we'll see what is the method where we can store on one bucket. Will be storing only single value, single record, or a bucket sometimes may store multiple values, multiple keys, or multiple records, right? So that is a bucket. So it's a single location of the hash function. So when we generate an address of a location, so actually what we do, we actually generate location of the bucket, right? Which bucket we are looking for, right? Which bucket which is actually storing the data we are searching for, right? So the idea with hashing is to turn a complex input value into a different value which can be used to rapidly or fastly extract or store the data, right? So to store this data or to access the data from, we use bucket concept. Okay, so bucket is a single location of the hash table which may store a single value, single record, or multiple values or multiple records, right? So what is a single value? Suppose like each student has a roll number, so it's a single value. But what is the record? Roll number, name, address, email ID, contact number, class, year, branch. So for one student, there are number of values, so that is called as a record. So single value is roll number, multiple values associated with that roll number is record, right? A single object, student is a single object, multiple values is a record, and multiple records means for multiple students there will be multiple records, right? So a single bucket can store a single value, a single record, or multiple records, right? So that is a bucket, and it is a single location of a hash table. So if there is a hash table, of size 100, of size 100. So how many buckets will be there? If there is a hash table of size 100, how many buckets will be there? How many buckets? In a hash table of size 100? Come on, answer it. If we have a hash table of size 100, so I told you that single bucket equal to single location, right? So if a hash table is having 100 size, 100 locations, how many buckets it would be consist of?
100.
Yes,
100.
it will consist of 100 buckets, right? So we'll see now next after bucket. So we understood bucket now, right? Now, what is a collision? So collision means what? Like on road also we see that sometimes two vehicles come in front of each other and then there is a collision, right? So why there is a collision on road also? Why there is a collision on road, on highways? Because they are using the same area on the road. They do not use different area. Okay, so if they choose different area to travel, so there is no possibility of collision, right? Similarly, in hash table, when we store the values, store the keys, so we know each value we store in a hash table has its unique location और must have its unique location. तो हर एक वैल्यू जो हम स्टोर करते हैं हैश टेबल में तो उसका एक सेपरेट लोकेशन होना चाहिए, उसके एक सेपरेट इंडेक्स वैल्यू होनी चाहिए. Then we can say that that is an efficient hashing or efficient hash table, right? So if like here you can see for 345 mod 10, what is the location for 345? Location number 5. For 495 also there is a location number 5. So 345 and 495. So if 345 is coming first, so 345 will be stored at location 5. So on location 5, 345 is already inserted in a hash table. So when 495 comes for it, again the same location address or index is generated by the hash function. So when there are multiple keys or when a hash function generates an index or a location of the hash table which is already occupied, or already we have some value, some record stored in that location. So that is called as collision. So here you can see a collision occurs when two keys are hashed to the same index in a hash table. जैसे रोड पे भी एक्सीडेंट क्यों होता है? When two vehicles are using the same area of the road, right? That is why there is a collision, right? Similarly, in hash table, if two or more keys are hashed to the same index in a hash table, or already there is some key value placed in a hash table, and when we try to insert a new key or value, the same location is generated which is already occupied. So that is called as collision, right? So collision is a problem because every slot in a hash table is supposed to store a single element. हमें पता है कि hash table क्या है? Is a data structure which provides a unique location for each and every value it stores. So if there is a collision, it's a problem. That means we are not using an efficient hash function because it is generating what? The same index for multiple values, right? So either we should change a hash table or we should change a hash function. या तो hash function को change करो जो क्या कर रहा है, क्या कर रहा है वो? It is generating same index, same location address for multiple key values. Or change the hash table if the location for which index is generated, address is generated by the hash function is already occupied, right? So either change a hash function or change a hash table, right? So isko hum dekhenge how to handle collision in the next lecture, right? So after this we yahan pe hame sirf samajhna hai what is collision, right? So collision aapko samajh mein aaya hoga, okay, when two keys are mapped to the same index or location of the hash table. So that is collision. Now, what is probing? What is probing? So when there is a collision, what we do? What we do? We try to find an alternative location in a hash table where we can place the key value for which collision is occurred, right? ऐसी की वैल्यू जिसको हम प्लेस कर रहे थे, लेकिन उसके लिए जो लोकेशन हमें मिला वहां पे ऑलरेडी वैल्यू है, ऑलरेडी रिकॉर्ड है, so we cannot place over there. So when we try to find out alternative location in a hash table to place the key value for which collision is occurred, that process is called as probing. That process is called as probing. Now there are different types of probing like linear probing, quadratic probing, rehashing. So हम देखेंगे what are these types of probing, okay, when we'll see how to handle collisions, right? So यहाँ पे you need to understand what is a probing. So what is probing? Finding an alternative location in a hash table when the key to be mapped encounters collision, right? So next is synonym. So what is synonym? When multiple keys will have a same hash key or same index value, same location value. So those number of keys are called as synonyms. जैसे in English, what is called as a synonym? The words having same meanings, right? Similar meanings. So they are called as synonyms. Similarly here in hash table, what is called as synonym? Synonyms are the keys or values to be placed in a hash table having same key values, having same hash key or same location generated by hash function. So if there are 10 keys having same index value generated by hash function, so those 10 keys are synonyms. Like here you can see in the example, for 345 hash key is 5, for 495 hash key is 5. So 345 and 495 are synonyms. Now what is overflow? Okay, you can understand by the name itself. It occurs when a bucket is full and we try to insert a new item in it. So I told you a bucket can store a single value or multiple values, a single record or multiple records. So if the bucket is full, maybe it is storing a single or multiple values. But still, if a bucket is full and we try to insert new items, new keys or records in it, so that is called as overflow, right? So we have to tackle this overflow by search the hash table in some systematic manner. If the bucket if the bucket is not full, then only we can insert. Otherwise, find alternative locations using linear probing, quadratic probing, and random probing. Okay, so that is a process to find alternative locations to place key values, right? After that, what is the load density? So what is the load density or load factor is how much your hash table is full. How much your hash table is full. So it's a formula to understand how much table is full. So there is a simple formula n by t. So what is this n by t? N means number of entries in the table and T means size of the table or capacity of the table. So here in example you can see there are table sizes 10, entries are 5. So 5 by 10 is 0.5. So if we convert this 0.5 into percentage, it is 50%. So table का size अगर 10 है, if the table size is 10 and we have inserted 5 values, so the load factor or load density is 0.5 or 50%. If we have a table size of 10 and we have inserted 8 values, then what is the load density or load factor? Then what is the load density or load factor? Table size is
0.8.
yes, 0.8 or 80%, right? So if the table size is 10 and we have inserted 8 elements, so 8 by 10, 0.8 or 80% is a load factor or load density. Simple formula hai. If table size is 100, table size is 100 and you have 60 entries, you have 60 entries. So what is the load density or load factor? 60 by 100. So what is the load density?
60%.
60%, right? Or 0.6. So we can use this load density or load factor to understand how much hash table is full. So we can keep a condition. If the table is 80% full, we have to migrate or we have to change this table into a big size table. We have to convert this table into a big size table. So that is called as rehashing. Okay. So when we do or we change the table size, we use this factor, load factor or load density. And last is what is full table. So when table becomes full, that is called as full table, but it is not full means 100% full. So if we specify that if it is 80% full, its density or factor is 80% full, then we can say that table is full. So we have to specify the load density or load factor. If somebody may specify it 60%, some may specify it to 80%, but after that we will display a message that table is full. So when we create a new hash table, so after the table is full, so it is having double size. So initially if the table size is 10, it will be 20. If it is 100, initially it will be 200, right? So that is what we do when the table is full. And this is done by rehashing. So what is rehashing? When we change the size of the table to double the size, then we do rehashing. That is, all the elements in the old table are mapped in a new table. So they will have different keys, different values, hash keys using a hash function. Okay, so when we change the table size, we need to map the keys from old table to the new table, and that process is called as rehashing. So we have to apply hash function on each and every key value to place it in the new table. So that is rehashing, which we do when the table is full. So this is all about basic concepts of hash table, which we covered today. So just a recap, let me tell you what we have studied. So we have studied what is a full table, what is load density or load factor. We have studied what is a table overflow or bucket overflow. Then we see what is a synonym. Okay. After that, we have seen what is a probing. We have also seen what is a collision. We have also seen what is a bucket. Then we have also seen what are the basic operations on hash table. Then what is a hash function? What is key? What is how we process that key using hash function, and it generates a hash key, that is a index or location of the hash table where we place that key or value. And then what is a hash table? It's a data structure. And what is hashing? Which is a process to map a key or value into the hash table using a hash function. So these are the concepts which we have seen today. So if you have any doubts related to any concept, you can ask. I have displayed the concept which we have covered today. So if you have doubt in any of the concept, you can ask.